Okay, so now that we have calculated a lot of seismic attributes, we're going to try to cluster them using some unsupervised machine learning. So we're going to go to the Artificial Intelligence Toolbox, Machine Learning Toolbox, Unsupervised, Step 1, Generate Training Data. And so the first thing to do is to add the attributes that you want to look at. I'm going to choose some of my favorite, which are the energy ratio similarity. Hold down my control button. I'm going to choose GLCM dissimilarity, energy entropy, and homogeneity. I'm also going to pick out my peak frequency, my peak magnitude, spectral bandwidth, spectral roughness, and spectral slope, and hit OK. We are going to run it through all of the data. So let me go down here, and I'm going to just stop it at 700 and hit extract unsupervised training data. Alright, we finished with step 1, so now we'll move back to the AI toolbox, unsupervised, step 2, and we will analyze the unsupervised machine learning now that we've decimated the training data. So for our input training data, we'll select the training that we just created by decimating through the attributes. We can see all of our list of attributes, and for now we're just going to leave it as a z-score normalization. I'm going to set my parameters to 10 processors, and then scroll down and choose k-means. So we're going to look at k-means and analyze how many clusters we should use, so I will execute k-means now. So after analyzing the input, a bunch of different plots showed up on my screen. We looked at all the clusters, and you can see here in this case, with this kind of scree elbow plot, 8 clusters is determined to be optimal. We also have some other plots that I'm just going to show you a few of that just look at the k-means projection in terms of how it clustered, the density of each cluster, and then, sorry, these are all on my other screen, and then histograms of the k-means clusters in different projections. So all of those are interesting, but the one that we need as we move into the step 3 would be the number of clusters we want to use. So again, we will select our clusters, or our training data. We've got our attributes, same as before. We're going to keep everything the same. And then we will go back to the main page. And since we're running a k-means model, I'm going to go to k-means, and I'm going to tell it to keep 8 clusters, and then I will hit execute. So in that step, we created the model, and now what we want to do is move on to step 4, where we perform the classification. So here's our k-means model. We're going to select it. We've got all of our inputs. We could change around the vertical limit if we just want to look at certain parts of the data, kind of zoom in, because that model will be over most of the data set. And then I will go back. We've got 3 principal components, and I'm going to click execute classification. So that step took a couple minutes, and now that it's done and we see the normal completion, we can move on to the next step, which is step 5, where we will take our results and we will co-render them. And so here we can select, these will be under, let's see, k-means axis 1, we'll assign that to red. K-means axis 2 we'll assign to green, so we're doing a red, green, blue plotting. K-means axis 3 we will assign to blue. Okay, so we can again do all sorts of different plotting options, but you know, we just want to look at this. And so we can now move through our k-means model where we can see the various different clusters that were found, and we could plot it in both the vertical section and of course we'll look at it really quickly in map view. And that just takes a second to run. Okay, and now we can look at the results. And here are our k-means cluster. We can move through our data.